but it's not certain. So today, if you're in a data center, you're mostly using NPO. If you're doing the backbone of a building, you're mostly using 2-core. And even though today there's not much applications for an OM5 on 2-core, it does seem like it's a logical choice if we want to be ready for those future applications. That's where the developments are going. So if we install OM4, we know that we will be very limited for WDM. If we install OM5, we know that we will have a much higher chance of accepting the signals. What signals? I can't guarantee anything. It's changing too fast. There's developments, there's technical aspects, there's cost aspects, there's the market acceptance. We cannot be certain of that future. We can just go by probability and say, well, OM5 is a good choice if I want to increase my chances. But afterwards, it is more expensive than OM4. So is it worth it? I don't know. I am finishing early. That's great. We caught up 7 minutes. I am finished with this presentation. Do we do any questions here or no? Later on. Later on. Okay, so I would like to thank you for your attendance. I hope you liked it. And I'll be back for another presentation this afternoon. Thank you very much.
Thank you very much. I'd like to ask Mr. Ricard Mom from Fluke Networks, please.
Okay. Good afternoon. My name is Ricard Momme. I'm in charge of sales for the obvious region of Denmark, Poland, Finland, Greece, and Romania. At Fluke Networks, we use this management by Excel, so that's why I ended up here. This afternoon, I'm going to talk about Layer 1. This is a Layer 1 conference, and so I would like to talk about how we at Fluke Networks see it as a good idea to test Layer 1, and specifically this afternoon in copper testing, so long cables. This is a two-part presentation. I did the first part this morning with focus on fiber optics. This is available for anyone who's interested to download afterwards, but today I'm concentrating on the copper part. So, we have divided this into different parts. We call it our best practice, and we think about it as the things you need to do to ensure that you do a good certification testing. We have heard about the difference between verification, qualification, and certification. This is basically talking about certification testing. This is how it looks. I'll go back to this. We divide it into the basic test, which is what we always, the basic test is what we always do. This is the test we get either a pass or a fail criteria out of. And in the worst case scenario, if we get a fail, then of course we need to do troubleshooting. We need to find the problem and fix it. And in certain cases, we would like to recommend to do what we call extended testing. Tests that are not part of the basic test, that are not part of the normal pass and fail criteria. But in some certain cases, we would like to recommend it. We also talk about, of course, documentation and how you set the test up before you start. The reason we came to this conclusion and the way we are testing and recommending today is we went back and ask some 800, a bit more, 800 installers all around the world, what do you spend your time on? Which are your main trouble areas, the problem areas you can see? Do you have laser on this? Laser? Yes, do you have laser on? Like a point? Laser. Okay, okay, thank you. Okay, thank you. So we asked 800 installers, and the reason we asked that few, if you like, is that were quite large, and together they make 1 million measurements per month. So this data come from 1 million measurements per month. So we think it's valid data, and it should be valid for most of us. Just to quickly explain what this means. A wrong copper limit basically means that you have your tester, but you put in the wrong limit. You're supposed to test category 6A, but you put in 5B, for example. So it's the wrong limit. Incorrect cable IDs. You have a lot of outlets to test, but you're not testing the right one, or you're not labeling them right. So you mix them up. Consolidating results. That basically means that you can have several testers, several technicians doing tests in the same building on the same project. But when you take the testers back and collect the results, you mix them up. So that's what we talk about when we're consolidating results. Setting up the copy test, that's basically user error. You do something wrong when you set it up. Evaluating OTDR traces, that has to do with fiber testing. Won't cover this today. Wrong fiber limit, of course, is also to do with fiber testing. Negative loss is also a fiber parameter. But troubleshooting copper is something I'm going to talk about today. Troubleshooting, hopefully, is not something you spend a lot of time on, because if you've done your work correct when you did an installation and you tested, you should get a pass. But sometimes you have a failure, or you go back to an old installation and you find some problems. Then you need to troubleshoot the problem. Okay, so traditionally we have had instruments we put in the hands of technicians, and the technicians themselves, the users, were responsible for setting the test up, putting all the correct parameters in, probably from a paper or something similar, or from a data file they got from their manager. The risk as we see it, and the real problem as we often see it, is that there is actually either something wrong in the documentation from the beginning, or something wrong when you put it into the tester. So something goes wrong. One way of fixing this is by centralizing all the management of all the testing in one point. So nowadays, we have a cloud-based software service we call Linkware Live, which is a cloud you log on to from your PC or tablet or whatever you're using. And you have one manager who's actually know what he or she is doing, sets everything up, and then sends out all the setups projects to the tester itself. The user then logs on, which is username and password to the machine, downloads only his work for the day, go out, does his work, and then sends it back again. And of course, then you can see if everything works as it's supposed to. And if you're using some other form of documentation software like AutoCAD, NetDoc, or whatever is popular, then of course you can import all the data directly from Excel as an example, into our software, and then further reduce the risk of error. So if you already have your project, like the cable IDs, for example, documented in another system, you can import it directly. Oh. Okay, basic testing. If you've ever used a cable tester, you know there is a long, long, long list of different parameters on there that should all supposed to have paths after them. What you might not know is that we're only measuring a few parameters like length, insertion loss, near-end crosstalk, and far-end crosstalk. All of the other parameters are actually calculated from these measurements. Just some basic background if you're not work with cable testing. We are talking about the link that we are actually testing, which is just the cables usually inside a wall. And if you also include patch cables, we talk about the channel. We normally do link testing. We only test this part. You can, of course, test the channel from end to end, which includes the patch cable. But we don't recommend it, because if you also test the patch cable, are you sure that if you come back after a week, a month, it's the same patch cable in the same places? No, of course not. But you can be pretty sure that the link inside the wall will stay the same. Therefore, we provide our patch cable. We call this a permanent link, because this part, the cable, is a part of the test instrument. So the actual measurement starts here and ends here. So this cable, our reference cable, is ours, and we control it, and we promise that it will work. They say that a picture speaks more than 1,000 words, but I think it's better that I explain this picture. We have heard before talk about old cabling systems that today are moved up to higher speeds. We're talking about going from 1 gigabit to 2.5 gigabit, 5 gigabits on existing cable system. What I want to show with this picture is the relationship between how much of the cable affects the quality in terms of the connector. So if you go from a lower frequency to a higher frequency, you can see, well, you're supposed to see that the connector part is actually increasing. So on a higher frequency, higher speed, then the connector is a bigger part of the problem, if you like, than the cable itself. So our recommendation, if you want to upgrade the speed on an existing cable system, is look first at the connectors. Look first at the connectors. That's likely where you'll find the problems. And this is how our reference connector looks. And this is actually a cable you can use for a year on a daily basis. And when you have used it about 5,000 times, you'll just exchange the tip of it. Yeah. I was joking, if everyone was using this type of cable, we wouldn't have much problem. But then again, we wouldn't have much money either. So. I talked before about the difference between link testing and channel testing. So this is something that shows how we think it would be a good idea to actually test the whole channel. You test first the link inside the wall, and then you test the patch cords separately. So if you have tested patch cords and you have tested link, then we can actually ensure that the whole channel is working. But you have to remember that these patch cord test heads are different from the ones that test the channel. These are specific to every type category of the cable you want to test. So if you have a category 6A cable with 6A connectors on, then you need to have the matching head here. Okay, extended testing. You've done this test and you've got a pass and a fail. Hopefully you got a pass. In the European standards, this is the list. We call it reference conformance testing. This is what the supplier or the manufacturers of cables test in their factory, all these different parameters. They test all of these, or should, before they sell it. In the field, we talk about installation conformance testing. Then you test most of these parameters, but you can see that some of them are not tested. Actually, length is not a parameter we test, which is a bit surprising perhaps. You would think that length is an important parameter. But we're actually looking at things like insertion loss instead. So you can have a cable that is 95 meters long, but still passes the test, even if you're only supposed to have maximum 90 meters. Resistive unbalance, and this one, TCL, ELTCTL, which stands for transverse conversion loss, or equal level transverse converse transfer loss, if I remember correctly. are two parameters that is not part of the pass and fail normally, but we do recommend that you test them anyway. And the reason to do that, I have an example here. And if you really pay attention now, you can see that this is example 2. So if you wonder what happened to example 1, you have to look through the whole presentation. I'm shortening it down a bit for time. In this case, a customer, this is a real-life example. A customer bought 2 drums of cable, identical drums, at the same time from the same manufacturer. So the 2 identical cable drums. They installed them and did all the measurements and got, as you can see, good results, passed on everything. They had a certificate, they delivered the certificate to the customer, and everyone was happy until 1/3 of the links didn't work at 1 gigabit. And no one could explain why. Until they made this additional measurement and measured TCL. On one, it was really bad, on the other, which was good. Then you can see that there actually was a difference between the drums of cable, and in this case it was a manufacturing error. So there was actually a problem with them from the start. And of course this was quite expensive, because then you had to take out kilometers of cable and replace from the installation. If they tested this from the start and included this extra test, they would have noticed it immediately. On the 2nd or 3rd test, they would have noticed this. So that's why we say, include this, do it every time, and you can avoid troubles like this. But you have to do it yourself. The instrument will not do it if you don't ask it to do it. Another parameter that is becoming increasingly important and popular has to do with power over Ethernet. Today we are talking about not only about 15 watts or 25 or 51 watts, we're talking about 100 watts. Next time is 100 watts transmitted together with the data over the cable. And as you know, it's 48 volts and it's 100 watts. So you can imagine that we're talking about some heat being generated here. And the reason for this is now that before we used 1 pair for data and 1 pair for power, but now we use all pairs for data and all pairs for power. So if you have a problem with the power feeding, it will surely affect the data on the cable as well. The measurement itself is very easy, very straightforward measurement. You actually only measure the resistance on the pairs, and then you compare the resistance pair by pair and look if you have a balance or an unbalance. But even a small unbalance when you're running 100 watts can lead to a huge problem. So we absolutely recommend that if you're doing the installation or looking at the cable system today, and you know that power over Ethernet is going to be used, make sure you test this parameter. It will save you a lot of trouble if you have this data with you. And as I said, this is not part of the standard. So if you just do a normal certification installation and get a pass or fail,